Hello everyone. I am Mohammed Tawfiq, teaching assistant at Faculty of Computer and Information Science at Ain Shams University. Today we will talking about two papers, not only one paper. The first paper is talking about benchmarking Euro variants for underwater pollution detection with collaboration with Dr. Soha Shabaka from National Institution of Oceanography and Prof. Wael Badawi from Faculty of Artificial Intelligence at Egyptian National University. This is our agenda. First of all, we make this research because we saw this underwater pollution poses major environment risks in our life, and manual detection is very slow and inconsistent. So we make an AI-driven solution to make the possibility of detection of debris and wastes in underwater be automated using AI. We used YOLO, and this is an algorithm for object detection and benchmarking for 5 versions of it, from version 8 and version 12, and comparing their results. Okay. This is our dataset. It was split for training, testing, and validation. Train images was approximately 3,600 image, and the validation 1,000 image, and testing about 500 image. The dataset is about 15 classes among different wastes underwater, like masks and cans, net gloves, plastic bag, and so on. This is example of our dataset. On the left hand, this is images before detecting using YOLO, and on the right hand, after detecting using YOLO. As I said before, this is our 5 versions benchmarked from version 8 to version 12. We trained our models all the same hyperparameters, 50 epochs, batch size was 16, and the input size of image 640 pixels. This is our evaluation metrics. We evaluate our model using mean average precision and recall and inference speed. And in mean average precision, we used 50 intersection over union, and from 50 to 95 intersection over union. Now, this is our metric. We will compare. As you can see, YOLO version 12 performed best among the 5 YOLO versions used, with highest mean average precision, either at 50 or at 50 to 95. And the worst YOLO was YOLO version 10. This is also comparison between precision and recall. And as you can see, YOLO version 9 achieved the highest precision. And this is inference speed, the speed of each model for detecting each image. And YOLO version 11 achieved the best time to detect the image. And this is a trade-off between precision and recall for every version used. Why YOLO version 12 performs best? In YOLO version 12 used mechanism of attention called area attention, that is improve and focus under low visibility of features in the images of underwater. And used also RELAN, which is a residual technique used to improve the performance of other versions of YOLO. And using flash attention to make memorize for the model for each training set image, and don't make using of GPU and memory very exhaustive. YOLO version 11, YOLO version 10 perform worst because they used a lightweighted architecture for their model, and the lightweight of this architecture makes the YOLO version 10 makes the features detected not good for achieve a better and higher accuracy. Our recommendation for best accuracy, YOLO version 12, for best precision, YOLO version 9, fastest real-time, version 8 and version 11, and balanced option, version 11. So, for conclusion, YOLO version 12, most accurate model for underwater debris detection. YOLO version 8 recommended for real-time applications. Pre-processing crucial for underwater visibility. I want بس on our dataset, we made a pre-processing technique called dark barrier channel, and this is used to remove haze from images, as images underwater contain a haze, and we used it to remove it before we add the images to our models. Thank you, and I'm open for any questions.
Yes, thank you, Mohammed. Is there any question? Okay. I have one question. I think your contribution is only to prove that YOLO version 12 behave accurate in underwater detection, underwater pollution detection. That is the only your contribution in this paper?
Yeah.
Okay.
This was a project. I'm using, was a teaching assistant at Egyptian Russian University. And
you
this
study
was,
only the problem of underwater pollution detection.
yeah.
And compare different YOLO versions on different datasets.
Yeah.
But I think you use about 2 datasets only?
It's only one dataset on 5 versions of YOLO. Only one dataset.
Okay. The second one is the same? Okay. Did you make any comparative analysis with other research for underwater pollution detections to show that YOLO version 12 is the accurate one?
This is our future work. But for now, this is only the work done.
Okay, thank you. Anyone have any question? Thank you. Any question, Dr. Hanan? Okay. حاجة جديدة بقى. Performance evaluation of YOLO models for sign language detection in another application. Okay.
Okay. Now this is another application of evaluation of YOLO models, but now on sign language detection with collaboration of Dr. Wael Badawi. As before, comparison between 5 versions of YOLO from version 8 to version 12, but on a different application, on detection of sign language. Now this is the size of our dataset, approximately 6,000 image. For
Before
approximate
beginning, Mohammed, you speak about sign language for any language.
sign language. Sign language.
For any language.
American sign language.
Okay.
Okay. This is example of data set before and after detection. As done before, nothing changed. As you can see, the 5 versions in these applications behave approximately. Nothing better than other. But the model achieved a better time with other versions was Euro version 11. Achieved good time with comparative with other models. But in other metrics, they behave the same, approximately. This is model recommendations, but I think the best model to be used in this application will be YOLO version 11 because all the versions behave as the same approximately, but for real time and better time time for detecting the image, YOLO version 11 behave better than the other models. I want only to talk about pre-processing done on the images before we added it to the models. We done on it random flips, crops, rotations, and shears, salt and pepper noise to make the model more generalized with dealing with this type of images. Thank you and any questions. واسمحوا لي بس كنت عايزه اتكلم بالعربي شويه في حاجه. هو المشروعين دول انا عارف ان ممكن يكونوا مش اقوى حاجه، بس هو كل الفكره ان انا كنت اصلا معيد في الجامعه الروسيه قبل ما اتعين هنا في الكليه بتاعتنا في جامعه عين شمس، وكانت دي مشاريع كنت شغال معاها مع دكتور وائل بدوي، فهو حب ان هو ينشرها ويعرضها في المؤتمر هنا.
Which type of projects? Which type of projects this project?
I can't understand.
أي نوع من البروجكتس يعني؟ انت بتقول دول two projects.
مشروع بحثي، مشروع what is the type of project؟
معلش مش فاهم قصدي حضرتك والله.
يعني نوع ايه من البروجكت اللي انت بتقول دول؟
هو نوع البروجكت نفسه هو الاولاني كان مع دكتور نهى اللي هو بتاع المصايد السمكيه، ان هو يتم الديتكت بتاع الوشس اللي موجوده اندر ووتر باستخدام الاي اي. ده كان الاولاني. والتاني
يعني
بالظبط، فكان كان مشروع والدكتور حب ان هو ينشره في مؤتمر كنوع من انواع التوثيق للشغل اللي اتعمل. الساين لانجوج كانت برضو فكره ثانيه برضو في دماغ دكتور وائل، ان هو عايز يعمل اب ان يتم استخدام الاي اي في الديتكت للامريكان ساين لانجوج، وهو اللي طلب ان نعمل المقارنه باستخدام اكتر من فيرجن لليوم.
I think sign language for American language have a huge application and tools for sign language.
مش I agree with.
Do you compare your results with Arabic tools for American sign language?
I agree
do
with
a comparative analysis with your results and the result for other
fully
for American
agree,
sign language?
agree with your opinion, but I made what I asked about. He asked me to make 1 2 3 اعمل كذا 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 باستخدام كذا بس.
May I ask about a question, please? May I ask a question? For the sign language application, you said that it is for American English sign language. Okay, let me ask about, you know that every language have its own sign language.
Yeah.
Does your application can distinguish between the American one and any other one and reject it?
I think if we added a label for our data to say I say different data sets.
So if
As for Indian, I think there is Indian sign language. If we add a label for that for our model, if this is a sign language for American Sign Language or Arabic Sign Language or any other language, I think our model will can.
no, I need something like binary classification. So you would train your model on American Sign Language. So if if the model get is a query for example, Arabic Sign Language, you reject it and cannot identify, or he just identify the border of the hands. If he identify this means the model is working on identifying borders of the hand.
In this paper, it only works on detecting that.
Do you
But-
test it
Yeah, but on future work,
on other sign language?
no. Only
Okay,
test
thank
it
you.
only on the American Sign Language only. But I think it can be enhanced if we add another data sets. Our model can detect and differentiate between different sign languages.
Okay, thank you,
Thank you.
Muhammad. Thank you. The next one, next generation, MCTM, how AI is revolutionizing the decision support process.
Okay, my research
Yes, Sham.
title is Next Generation Multi-Criteria Decision Making. How AI revolutionizing the decision support process. We're gonna talk about what is multi-criteria decision making systems and its steps. We're gonna also cover some limitations of it, and we go through how artificial intelligence يعني change the core processes of multi-criteria decision making system through our framework is divide and inject. Okay, my research team, Professor Magdi Abu Laila, Dr. Randa Al-Wakil, and Dr. Basim Ibrahim. First, we're gonna have like a small introduction about challenges of decision making that we have all the every day we have to make decisions from trivial to complex. Trivial decisions or small simple decisions have one criterion and one preferences. One decision maker with multiple preferences. But when people more decision maker interfere or involved in the decision making, we have a complex situation because we have to satisfy all the preferences of these decision makers. What is multi-criteria decision making? It's a structured approach we use to choose between alternatives. These alternatives are measured through multiple and also conflicting criteria. This is done through several mathematical techniques. Multi-criteria decision making have more than 200 different mathematical techniques. Each one is different from other aspects for providing a comprehensive decision support process through various domains and applications. Okay, we categorize the multi-criteria decision-making challenges through the data challenges and methodological challenges. Data challenges, the decisions are, in final decision is influenced by data availability, data quality, and data clarity with uncertainty, and also the weights of these criteria are done through the decision makers. For that give us another challenge. It's a subjective judgment. Other challenge is methodological challenge that, as we mentioned before, is what we have more than 200 mathematical techniques for multi-criteria. We have to choose the right one to get the right answer or the more accurate decisions. If we don't, we will lead us to misleading results. This is also, I said, talked about it. Okay, in this paper we're gonna emphasize on how the importance of integrating artificial intelligence and multi-criteria decision making, and also we're gonna present how AI driven solutions and divide and conquer inspire our idea of the framework for restructuring the core multi-criteria decision making process for handling more complex situations and multi-criteria data to have the optimized and accurate decisions. Our framework is simple. It has 3 steps. First one is decomposition. We're going to decompose the problem to simple sub-problems, and then at each stage or each sub-problem, we're gonna inject the suitable AI technique for it, and then we recomposition all the results to have the final results. As we see in the graph, this is we talk about. We have a complex multi-criteria decision making. We have to composition process sub-problem 1, sub-problem 2, and until it ends. Every sub-problem we inject the suitable multi-criteria decision making to have, and then aggregate, and then we have the final output. It's the idea that idea of the framework. I'm trying to get the best input to have the best output. Okay, this is traditional multi-criteria decision-making steps. First one, define a problem and the objective, structuring problem, assign weights, evaluate alternatives, and select methods. Okay, we are going to talk about each of one separately. In step 1, problem definition, we have in this stage where I have to, decision makers have to define clearly what is the problem and what is the desired objective of it. It is decide it's a choice problem, rank programs, sorting, classification, or description problem. Okay, here we are going to inject AI techniques in the multi-criteria decision making steps. Previous step, we do it manually. We will start here from injecting the AI and traditional multi-criteria decision making. In this step, we have to also decision maker to define the criteria and possible alternatives for the problem in hand. The AI enhanced or AI injected technique could be ontology-driven approaches. It can dynamically generate criteria and alternative in a hierarchical and a consistency framework. فده طبعا this is increase the dynamic and it's knowledge rich framework for generating relevant criteria and alternative. تمام. Okay, step 3, it's AI driven criteria weight. In this step we have to give weights for each criteria and how it's important to the decision maker or to the problem. The traditional way decision maker did it manually, فده lead to subjective biases, and AI injected techniques could be fuzzy logic integration, natural language, and genetic algorithm. Right. Step 4, it's enhanced AI alternative evaluation. We now, in this step, we have to evaluate each alternative through the criteria we defined before. A traditional one, it's we have like quantitative or qualitative method to represent this alternative in a decision matrix. AI powered, we use convex quadrant programming, learn from previous preferences, and get the this evaluation mirror human judgment. Step 5, intelligent method selection. In this step, we have to choose the best method for the situation. Okay, this case study I will pass because of time. This is a summary for our comprehensive AI techniques. As shown, you have AI techniques, its role, and which step it's support the AI technique support in multi-criteria, and advantage and disadvantage, or limitations. Okay, key research findings. We enhance the accuracy through getting the best inputs to have the best output, and through reducing the subjective biases. Explainable decisions. We have also integrate SHAP values or local explainability techniques to have to increase to make the decision trustful from decision maker. وعندي هنا scalable framework. يعني we can have this process done and domain adaptability. This domain can be adopted through multiple applications and domains. Okay. And to conclude what we have done, the divide and inject approach decomposed the decision problem into modular subproblem, enabled targeted AI integration at each stage. والادفانتج اللي احنا زودناها في الاركتكتشر بتاعنا ان احنا عملنا combine اللوكال اي اي يعني governance وعملنا طبقنا الاكسبلينابيلتي وزودنا الروبوستنس خلال يعني اللي هي الرانك فلكتويشن والكاندل تكنيكس. طبعا غطينا التشالنجز وهنا الامباكت والبنفيت enhanced scalability, adaptability and explainability. We support local traceability. We lays foundation for next generation intelligent and trustworthy decision support systems. Thank you. Anyone have
thank
question?
you. Thank you, ma'am. Do you have any questions? Okay, I have question.
Okay.
You mentioned that you follow this process on 2 case studies. Is your own case study that you follow the process?
It's like an illustrative example. يعني أنا يعني I already implement this framework from يعني in another paper, and it's يعني I have
the implementation on this case study. It is
no, it's
not
different.
your own.
Different one. لا دي like I have يعني to illustrate the idea يعني and how I decompose the steps and then I يعني inject the AI techniques in it.
Okay. Yes, thank you.
Okay, while you're presenting, you said that you achieve better performance than others. How, as you said that it is just illustration, how you know that your approach is better results than others?
Okay, I use stability analysis. It's candle and rank fluctuation. I already implemented this framework, and also I comparing my results. I made like a baseline. I made the result with the core multi-criteria decision making steps without any artificial intelligence, and then I add one component with artificial intelligence and measure the rank fluctuation and measure the candle. This is a stability measures. Okay, and I have a better better results for these stability measures, and then I add more. It's like an application study. يعني أنا every step I use one AI techniques and have the final result, and then the next run I have I add one more AI technique for the next step, and then also I measure the candle and the rank fluctuation, until I finished all multi-criteria steps. Then I have the final numbers, and it was very, very, very differ than the base one. This is without any AI techniques.
Okay, thank you. But if you can explain this on your case study, how to follow the process for multimodal decision making on the case studies you mentioned, that it will be more explainable. Maybe you do this and in your paper.
What? Again, manage?
The following steps for multimodal decision making on the case study that you mentioned. You explain this in the paper?
Yes, I explained already in the paper, but also I want to explain or illustrate something.
Not
This is
the presentation.
What?
But you don't explain this in the presentation.
Because of time, but and I can go back and explain it. It's a case study. It's illustrative case study, but the real case study I did it in another paper. And this was also with the evaluation and results, or in another paper. This paper for me is like a survey, but in a different way, in a different point of view. I propose a framework, and then I give an illustrative example to make the audience understand my framework, and then have a literature review about previous researchers in this at each step. When I found it, I don't have a I don't see, or I don't find a comprehensive paper that talk about all the steps. Every paper is covering only one step. Like here, if I go back, I can show you. Okay, this table, I show the AI technique and its role. And the specific step, this is paper cover. Previous our literature work only use the AI technique to help multi-criteria decision making, or enhance multi-criteria decision making in one step. My idea, I have to make it like a comprehensive
the process. Okay.
Okay.
Thank you.
Okay. Thank you.
Thank you, ma'am. Next one, an enhanced explainable machine learning approach for livestock diseases classification.
Good morning, I am Aya Adil, lecture assistant in Faculty of Information System and Computer Science, October University. Our research is with title in Enhanced Explainable Machine Learning Approach for Livestock Disease Classification using Nitrosophic Set Based Feature Selections. It is prepared by Aya Adil, Iman Ahmed, and Noor Eddin Khalif. Our agenda contains introductions, literature review, proposed model, result, and discussions, and we conclude the paper in the conclusion part. In the introductions, we talk about livestock and livestock diseases and illustrate problem statements in an objective and our contribution. At the beginning, we must know what is the livestock. Livestock refers to any domesticated animals that raised in agriculture settings, like goats, cow, sheep, pigs, and poultry. It is raised to many purposes, such as food, labors, and other products. What is the livestock diseases? Livestock diseases refers to any illness affecting to animals, which reduce health, and this why it is important to detect and treat the illness or diseases in early stage, because it is the delay impact to the farmer income and the economy and affect for food security and public health. Problem statement. We know manual livestock diseases detections depends on human observations and vet visits, and it is maybe inaccurate, and it is very slow, and this delay it causes to higher risks of outbreaks and many losses. So we need to build an automated and accurate explainable system. Research aims, we aim to use the AI techniques to detect in early stage and make rapid diagnosis to enhance the welfare animals and decrease economic loss. What is our objective? Firstly, develop an AI model based for accurate disease classification and explain the predictions to preventing the outbreak. Our contributions, we use a nitroscopic set for feature selections to select relevant features from the dataset, and applied random forest for accurate and generalized disease classifications, then use explainable AI like J-BLEM to explain the predictions. This table summarize some articles have the same area but with the different data set, and the common limitations for all, they didn't use any explainable for the predictions. Our proposed model, firstly, we must discuss about dataset name with livestock sample and diseases dataset. It is downloaded from Kaggle website. It has 43,779 samples. Its sample has 6 distinct features, and it can belongs to 1 from 5 diseases. This dataset has many challenges like irrelevant features and class imbalance, noisy, and different scale for features, and this challenge may be affect to the accuracy of the model. This table presents samples for the data set, and according to histogram, we know Lambi and Phenomena classes have the smallest value for the sample, and it leads to the unbalanced data set. The methodology is our proposed model has 5 phases. Firstly, data preparation to solve the challenges for the data set, and secondly, pass to feature selections using a nitroscopic set based on calculating the truth and the false and the indeterminacy, then combine all of them to get the score and get the relevant more informative features. Then use the random forest according to the previous work, and random forest proved its efficiency in classification. Then use matrices to evaluate our model, and finally explain the prediction using explainable AI. The idea for the nitroscopic set feature selections: select the most informative feature using a nitroscopic set by combining T and I and F, by using computing Pearson correlations between each features and each class. Then according to these equations, and then use the correlation to compute truth and indeterminacy and velocity. Then use the hyperparameter to highlight the truth and ignore the velocity. This data set, after solving the issue and ready to enter to the feature selections using a nitroscopic set. This table represents the values for each feature and select the three top features is submit 1, submit 2, submit 3. We found them affecting to the classifications. After searching using already hyperparameter search, we get the optimal structures for the random forest, and it is maximum depth equal 7, with number of estimators equal 45. We apply these structures on the original dataset without any selections, and dataset with selected features using a nitrosophic set, and we note that the accuracy enhanced by 9.47%. Other measurement, representation and recall for the original data set and the selected data set, the result observed that and proves that the selected has efficiency for the classification. And it is the confusion matrix. We note that after using a nitrosophic set, the model misclassified only 119, but with the original set, the misclassified is 812. To explain the predictions and know the relationship between each features and affecting to the classified, we use shape diagram, and at the notes we note that feature 0 and 4 and 5 not affected to any class, but feature 3 and feature 1, feature 2 is affected mostly in the classification. And we to explain the predictions, we use the LEM explanations. The left numbers or left probability refers to the probability predictions for each class, and the right refer to each affected to each feature affected to the classifications, and we note that submit 3 affected completely to this classification. Conclusion, we we make nitrosophic feature selection with random forest, reduce features from 6 features to 3 features, and it is affected to the accuracy. We apply the shape and the limb explainable AI to explain the result. Future work, we can use multi-model data like signals, images, and sensor for reach predictions. We can collect tests for multi-farmers and multi-regions to make generalized for the models, and we can use real-time monitoring by using a web or a mobile app for detection diseases to help the farmer and vet. Thanks.
Thank you. Is there any question? Okay. Dr. Han have a question?
Okay, as the major or the main idea of this paper is to identify the diseases. Why we didn't go to image-based approaches? Why we go to random forest as a machine learning technique?
We already have another paper using the images data set, and we use submits to integrate between the two papers.
Okay. Did you make any comparative analysis with your results, other literature review that has the same application on the same data set that's using?
No, with the same data set, no. But there isn't the same idea, and they used random forest with accuracy 88.
Accuracy?
88%.
Yes, thank you.
Sorry, I have another question. The other algorithm with 88% accuracy, what is the size of the data set it used? The size of the data set used by previous technique or previous algorithm or previous paper you compare with?
We decide to integrate between an anthroposophic set and random forest to build a new technique depending on an anthroposophic set.
Okay, thank you. It's very good. Your certificate. Next paper. Number 5. Toward energy-aware AI optimization strategies and partitional guidelines.
Good afternoon. Today I will present my paper toward energy-aware AI optimization strategies and practitioner guidelines. This will be our agenda. We will start with the artificial intelligence evolution, passing by the techniques and the key recommendations. AI is the ability of machines to perform tasks that required mainly the human intelligence. There were a huge evolution over the previous 7 decades. We start with the foundation and simple expert systems, passing by machine learning and data-driven AI. Then we join the deep learning revolution when we start to need to pay attention to the model and the complexity of our model. And this because there are impacts of the huge size of the new models. There are, for example, we have 4 impacts like energy consumption. The training of the large models require massive electricity, and they are often comes from non-renewable resources. Second one is the water usage. Data centers need for cooling need much amount of money for water for cooling. AI infrastructure contributes to greenhouse gases, and the rapid hardware turnover generates electronic waste that usually we dispose them in an unsustainable way. And here there is an example, a numeric example with this graph. First, these are the cost of the training over the past few years. And this was reported in 2024 from the Artificial Intelligence Indexing Report. And these are the amount of emissions, the carbon emissions that comes from those training. And from here, the concept of the term green AI has appeared. Green AI formally was introduced in 2019. And the main target of the green AI is to propose models, but taking into consideration its effect on the environment. And from here, our main objectives of the paper is to see the different AI techniques that we need to insert to import in our pipeline, our development pipeline, in order to have greener models. Mainly, we classify them into 2 categories: model architecture optimization and efficient training strategies. The first one, the model architecture optimization, mainly covers the techniques that we need to pay attention while building the architecture itself. because the layers, neurons, and weights and its connection to each other affects or have a great impact in the training after that. First, there are an overcomplexity in modern models, and this mainly because of two main factors. The first factor is the technical factors, and this is because most of people, when they try to solve a complex problem, they tends to make their models deeper and increase the number of parameters. The other factor is the human factor, and this is because of the maths that the bigger means better, while in this is not true in real life. The first technique is pruning. Pruning is a technique in machine learning, especially in deep neural network. The target of pruning is to compress the model by removing the unnecessary connection and neurons. And this comes because some neurons and weights doesn't contribute equally to the output, to our output. Second technique is the quantization. Quantization was mainly developed as a compressed technique, while it can recently we can use to decrease the amount of computational and reduce the carbon emissions. The second category is efficient training strategy. The training is the second step, comes after building our main architecture. The training covers multiple points. We will talk about them each. First thing is the hyperparameter. The hyperparameter are defined before the training and control how the model learns. The values of the hyperparameter define or control if there will be underfitting or overfitting, and they are not universal correct values for hyperparameter, and this is because the hyperparameter values mainly dependent on dataset architecture and the task itself. In the hyperparameter tuning, we need to avoid brute force methods like full grid search and use more smart resources aware techniques that help us to reach the suitable or the most suitable values for the hyperparameters while keeping the computational cost to the minimum. The second technique is knowledge distillation. Knowledge distillation mainly is compression techniques that work in passing the knowledge from a teacher model or a big model to another model. The other model is more compressed and small. This helps in avoiding starting the training from scratch and make us use the already learned parameters and learned data and pass it to the student model, which makes the total training time decrease. Then the transfer learning, it's a bit different than the knowledge distillation, that here in the transfer learning, we need the both models to be exactly the same architecture, and we can pass the weights that we want, freeze some and fine tune others. And this help most of the cases, the output of this of the transfer learning is better than starting the learning from scratch, and that will take more time and more computational cost. The training location, this is the least the one that most of people didn't pay attention to. The training location varies in the amount of carbon emission that will be in the training phase. We can choose on cloud or on device. Why this matters? Because the source of the electricity differs from country to another. Some countries have renewable resources and others doesn't. So when we choose to train or on a cloud, it's important to to choose the location of location of a country that use renewable energy resources. This is the first and second thing, and we need also to schedule the training during periods of low carbon intensity, as there in the same country the carbon intensity differs from time zone to another based on the solar energy or fuel energy. The last thing, we need to prioritize the resources configuration, and we need to build our cloud on specific to the need, not much bigger that we also make idle resources while we already paid for that. Those examples for quantified energy reduction that happened by applying some of the previous mentioned techniques on different domains like NLP and image. There are huge energy savings, although they didn't do this to reach green AI. They do this just to compress the model itself. So we can sum up the key recommendation. First thing, that pruning is a corner case if we want to reduce the complexity and optimize the performance of our architecture. Secondly, is the quantization is effective post-training. In some cases, we couldn't apply quantization in the training time, but it's still an option we can apply post-training. Hyperparameter tuning algorithm, we should prioritize intelligent search over brute force methods. Applying fine tuning after knowledge distillation, that this makes us fine tune a more complex and small architecture. Always check for a pre-trained models and try to start from here instead of starting from scratch. And the last thing that we need to carefully evaluate the specific requirements of our constraints in the task that we are doing, which make and choose and determine the most suitable training location that we need. Those are my references. Thank you.
Thank you. Is there any question? Okay. You just make a survey for the problem and the strategies for. I think the table you mentioned, the last table you mentioned, that conclude all the strategies.
Sorry, I didn't get it. What the question?
Return to the tables that you explained in the presentation. Okay. This is a hot topic, and hope you very good chance in this. Thank you, Dr. Hanan. Thank you. The last one, diagnosis of diseases in color fundus image using deep learning algorithm with explainable visualization.
Good afternoon. My name is Muhammad Eid. I'm a biomedical engineering undergrad at the Higher Technological Institute. Actually, this is my senior year, and it's my pleasure to present you our research under the title of Diagnosis of Diseases in Color Fundus Images using Deep Learning Algorithms with Explainable Visuals. So, in our abstract, this research presents a robust deep learning framework for automated multi-category diseases recognition from retinal photographs. Scope is identify 8 distinct ocular conditions like DR, glaucoma, cataract, AMD, etc. Methodology is VGG16 architecture with transfer learning, and innovation is integrating the GradCam model interpreting And the key result is 92.7% accuracy in multi-diseases classification. So let's start with the why. Why we choose to work in this. So the burden or we're talking about today is the WHO or the World Health Organization reported that there is a 1 billion individuals worldwide suffer from preventable or treatable vision loss. So that like these massive numbers that you see here, we have the cataracts, 65.2 million, and glaucoma, we have 6.9 million. Diabetics and retinopathy is 3 million people. Okay, so what is the problem? Is just the diseases itself? No, there is a critical worldwide shortage in eye care specialists, creates substantial obstacles. There is no enough doctors in the developing regions to cover all of that, to do a full scan like we did here in Egypt. So to do that, we don't need just doctors. We need help from a person, a personalized, like the AI. Okay, so understanding the fonts imaging, we have fonts photographs that we use, which allows us to directly visualize of posterior segment of the eye, acting as a window to a vascular health. And we focusing on the retina, like the light sensitive layer, where early signs systematic diseases appears. Okay, sorry. So the proposed methodology, we used BGG16. I know we have a question about it, but let me answer it in my way. Okay, so for the BGG16, we utilize a transfer learning, taking weighted pre-trained on ImageNet to exclusively extract features like age and texture. And we split that model into two different users of it, or two primary modules. Multi-disease classifier, we identify 8 separate diseases, and the DR severity gradient. For one disease, we have 4 different levels, because every level of it need different treatment, different help from the doctor, or it used to give you another way about the person. Okay, so as we see here, this is a DR. We will focus on it because this is the only one we are talking about 3 or 4 levels of it. The first one with level, yeah, okay. We have the first level and the second one and the third one. Each one of these parts need a different treatment plan and a different care from the patient itself, or from the hospital or the healthcare organization. So for diabetic retinopathy, we are talking about simple detection is not enough. Our dedicated models grade the diseases across 4 clinically significant stages, providing crucial information for patient management and treatment planning. So let's solve the GradCam. GradCam, what is the GradCam? It's the solution for the black box. As an AI engineer or biomedical engineer or someone working in the field, I know how to trust my AI numbers. But doctors you will not understand these numbers. They need something to visualize. They need to see it in the way they like, the way they learn it. So how we can do that? We can use something called a GradCam. This technology stands for Gradient Weighted Class Activation Mapping. Okay, so what simply do, it's making a heat map for the image, and as you can see, it's like cold hot game. When you see the hot part, this is the most influenced. Yeah, the heat part here, this is the most influenced one for our model. So when doctor or clinician sees the AI, he want to see something he can visualize. So when you see this part and tell you, yeah, that's right. We are looking actually for this part in the image, and that's right. That's how we do it. So not just making it an AI. This is not our job. Our job is not making an AI for treatment and or diagnosis. We are making AI that can people trust. So the trustworthy point is very important. Like every like Dr. Shadi talked about it today. He talked about the board that he did a reconstruction, and the board that reconstructed used some another technology like the GridCam, so clinician can see if it's right or not. So that's what you're talking about. For the results, we have, as we say, that overall accuracy of 92.7% and 88.7% for weighted F1 score, 89.1% weighted precision. So it's for the ODIR system or ODIR dataset with like KGO that we used. We will see if this number is good or not. So Li and Wang, we have comparison between them. They use the same dataset, the same process they did on the data processing. So our approach is slightly better in the first one of them, like 2%. And for diabetic retinopathy FDR grading, accuracy is slightly better. It's 94.2%. Quadratic weighted kappa 0.896, which is a robust concurrence with specialist assessment, and weighted F1 score 94.0%, balanced precision and recall accuracy rates. So this is a visual for a verification for doctor to see. This is the original fundus images, and this is our GradCam map for the board that was heat mapped. So this was for IU, or the intersection over union, score confirmed anatomical prevalence 0.78 for DR, 0.81 for glaucoma. So in the end, if we want to make this AI better, what we do? Actually, we need to get more or better percentage accuracy. We need to, if we want to implement it here in Egypt, we want to work on more regional Egyptian datasets to be more accurate with the data here, and also, yeah, the GridCam. Okay, so maybe further suppose an equation. I would answer it first, then I will give you a moment to ask questions. Yeah.
Thank you. Is there any question? Okay, it is a very good work. You explain your methodology and you compare our results with other literature review. I see your paper must be the best paper in this session. Thank you.